In today's video, we're going to talk about the concept of cooking in TouchDesigner. Understanding cooking in TouchDesigner is critical to making your projects run smoothly and efficiently. The term cooking means when operators do work to produce their outputs. TouchDesigner is pretty great at knowing which parts of the project need to update at any given time and which don't. And you can get away without understanding how it works to a point, but especially as your projects get larger and more resource intensive, you're going to find that things run faster if you design your projects to take advantage of how the cooking process works. Let's first show a classic example, and then we'll dive into the rules for how cooking works. So here is a series of chops where we have a constant that's producing a value with some number in it, a filter that's smoothing it out over time, a math that's applying some multiplication or something to it, and then a null at the end that isn't doing anything. Even before we do anything to this, we can already see that the connectors between some of these operators are animated. So between the filter and the math here, or the math and the null, and then between the filter and the null here. So those are pathways where data is actively flowing from one operator to the next. You can middle click on any operator and it's going to show you this info pop-up. And part of what that includes is this total cooks count. So this is the number of times that this operator has done work since the project was started. So for an operator like filter here, you can see that it's continually going up. It's continuing to do work. But for this math operator, it's only cooked once and it's just holding on to whatever the value is the last time it did. So the total behavior of either of these chains is going to be the same. So if you change the input, it's going to smoothly transition to whatever that value is over a certain amount of time and then stay there. And then that value will be scaled by some amount with a multiplier by 10 in this case. So both of these are going to behave the same way so that what you see in the output is going to be the same, but they will have different performance because in this first case, we're doing our filtering before we apply the math. And in the second case, we're doing the math before the filter. And because of how we've arranged those, there's a different amount of work going on for every frame in the first of these than there is in the second. So in the second one, we only really have this one operator cooking on every frame, but in the first one, we have both of these are cooking. So by reordering these, the end result is the same, but the performance is going to be just a little bit faster. TouchDesigner executes a project in what are called frames. So every frame, and by default, there are 60 of those every second, things in TouchDesigner will update. So these updates are based on a pull of data starting at the end of the chain and then pulling from the inputs, which pull from their inputs and so on. So first, it will determine which operators need to run for the current frame. And each operator has different rules for when it decides that it needs to cook. And there are 3 different variations of that. So there is the always cook, there's the always cook if asked, and then there is what's called on change. The first type of behavior are operators that are going to cook every single frame, regardless of anything else that's going on around them. So for example, the audio stream out operator is always going to cook on every frame as long as its active parameter is on. So you can see here, this number is just continually going up. Even though the input isn't changing, it has to continue sending stuff because otherwise, that stream of audio would be interrupted. But if we switch that active parameter off, then suddenly it'll just sit there. There aren't a ton of this kind of operators, and mostly those are related to things like sending data out of TouchDesigner. That could be like sending audio somewhere or displaying a window or, sending some kind of signal over a network or something. So any kind of operator that needs to be sending like a constant stream of data out, those are going to cook on every frame. So next are operators that will always cook if something is using their output. And that could mean that they are connected to an always cook operator. Like if you were connected to this audio stream out, then it's always going to continually ask its input for data. And because of the rules of how filter chop works, it's always going to do a calculation. And even if the result isn't the same, it's always going to keep doing that. Another thing that can cause an operator cook is having a viewer active in a network editor. So right now we're seeing viewers for all of these operators. So they're all being asked to cook on every frame, but for some of them, like filter, it's going to do that work every frame since it's being asked. But for others, like the math and the constant here, those follow a different rule. So even though their viewer is showing, they're not necessarily doing any work on every frame. So filter shop is a good example of this. So if this was not connected to an audio stream out and we were to turn off the viewers here, then suddenly it's going to stop doing work, and you can middle click on it and see that it's just sitting there. So filter is an operator that if needed, it will cook on every frame, but if nothing is paying attention to what comes out of it, then it's not going to do that at all. The last type, and one of the most common, are operators that will cook if they're asked to, kind of like the previous kind, but only if one of their inputs or one of their parameters has changed since the last frame. And when I say changed, that also includes operators that are cooking in the current frame, even if the results they produce happen to be the same as with the previous frame. So in this example, this math chop here is cooking every frame because its input is cooking every frame. Even though right now that number is staying constant, it's still doing its calculations on every frame to produce a new value that just happens to be the same as what it produced on the previous frame. And this is where that difference in performance and difference in the amount of work comes in. So because we have this filter, and filter is one that's always going to be doing something as long as something's paying attention to its output, because we have this before the math, then it's always changing, and therefore everything downstream of it will think that its input is potentially changing, so it's always going to do work. Whereas in this case, the math operator is only changing if its inputs change, which is just this constant. Nothing's changing that, so it doesn't need to do anything. So those are the different types of ways that operators will decide whether or not to cook. So now we can talk about how we can use that to make things run more efficiently. The first principle to keep in mind is you want to have as few operators cooking as is needed to do whatever it is that you want the project to be doing. And one of the cheapest, simplest ways to do that, to have fewer operators cook, is to either turn off the viewers like that, or not have a network editor open in the first place, or have it, somewhere else. So when we're in a network editor out here, it doesn't need to show viewers for any of the things that are inside that project one comp. So they don't necessarily have to cook. Although in the case of something like that audio stream out, it's going to do it anyway because that's just the rule for how that operator works. There are some operators which will selectively request data from one or sometimes more than one of their inputs, but not all of them. And switch top is a good example of that. So here we have two operators that are playing video files, and then, we're applying a little filter on that. This is another noise top, and we have an expression and a parameter that's changing every frame. So this is considered to have its inputs changed. Now, if we turn off the viewers on all of these and we just keep it on the switch, then because of how this parameter is currently set, it's only pulling from that first input. So while these operators are cooking, these ones are not. It does have this option to blend between inputs, and in that case, depending on what the value is, it might grab from two at the same time. So right now we're between 0 and 1, so it's going to be grabbing those two in order to be able to blend them. And then as you change the value, it's going to change which ones it's pulling from. Switches are a great way to avoid having things cook unnecessarily. If you have a few different things generating video and you only really need one of them at a time, then you can use a switch top. And as long as there isn't anything else that's causing those tops to cook, like if they had viewers active or something, then they'll just sit there idle and they're not going to take up resources. The second principle to keep in mind is to pay attention to which operators are costly and be selective about when and how you use them. So there are some operators that cost a lot more in performance than others. And script operators can often be an example of that, especially if the Python code is doing a lot of work. And often operators will be more costly when their input is larger. So like with SOPs, if there are a whole lot of vertices coming into it, then it's going to have to do a lot of work to do whatever it does to those. Or for tops, if the texture coming into it is particularly large, then it has to do a lot of work to come up with the result on every frame. So in a lot of these cases, it's going to depend on the size of the input and what the parameters are. So there could be one combination of parameters on an operator that is, not particularly costly, but another that is way more resource intensive. So it would be great to have a way to find which operators are currently taking up resources in the project. And fortunately, there are two tools that come with TouchDesigner that can help you do just that. The first of these tools is the Performance Monitor dialog. You can get to this by going up to the menu and clicking Performance Monitor or hitting the Alt-Y shortcut. The first time you open this, it's going to be empty in this main area, but on the bottom left, there's this Analyze button, and you can click that. And the next frame it runs, which usually happens pretty much instantly, it's going to keep track of all the things that it had to do to make that frame happen and how long each of those steps took. So we'll list out in this window here all the different steps, and the green bars underneath it indicate how long that step took. A lot of the things that show up in here are going to be these cook items, and those will give you the path to a particular operator and that'll show how long that operator took to cook. So in this case, we can see that movie file in 2 within project 1 took a decent amount of time, and movie file 1 also took a sizable chunk there. And those operators will often take longer to cook because they'll have to read files off of the disk. Optimizing video playback is a whole other topic, so I may save the details of that for another video, but just note that some operators like this are going to take longer than others. You'll also notice that a lot of the operators that it's talking about in this dialog are things like, /UI, /dialog, and so these are parts of TouchDesigner's UI that are made out of TouchDesigner components. So for example, this whole bar at the bottom here and the menu bar at the top, the toolbars, all those buttons there, those are built out of TouchDesigner components, and showing those on the screen has a performance cost. So it's not typically a lot, but it will be some. You can filter down what's shown in this by using this filter field here, although note that you need to have a star at the beginning and the end if you want to match part of the text. So if we search for project 1, we put a star at the beginning and a star at the end. Search, it's just going to show only the items that contain that as part of the text. So this will show only the cooking for the operators that are in our project 1 component. And if you want to clear it, you just have to clear the contents of that field and hit enter. While many of the things that show up in this dialog are the cooking time for a specific operator, there are also going to be a bunch of other things that are kind of part of TouchDesigner's under the hood activity. So some of these like MIDI event checks or these processing value changes is one that's a little bit mysterious, but often the biggest thing that you're going to see are something like rendering a window or presenting windows. So here we can see that actually the majority of the time for the frame that we analyzed here was spent with rendering a window. So these tasks are a little bit harder to track down. Often when something like rendering a window or presenting windows is taking a really long time, it means that your GPU is overloaded. Or in cases where you're already hitting the target frame rate. So here we're asking Touch to produce 60 frames a second, and it's actually hitting that. So in order to not send stuff to the GPU outputs faster than they can handle. It's kind of waiting a while to make sure that things stay synchronized. So that's where some of this time comes from. If you have heavier stuff going on in the project, then the ratio of that to the other stuff might change. There's also a feature where you can set this number of milliseconds. So if we set this to like 30 or something and hit analyze, then it's going to wait until the next time that a frame takes that long to cook and then analyze that one. So I have a bunch of complicated stuff in this base here. So if we show a viewer here, then it's suddenly going to slow down. We're down at 9 frames a second, and it will analyze the first frame that it got when that happened. So here we can see that there's a whole bunch of work going on for these SOPs that are inside that component. That feature is a good way to track down issues where the project is, running fine most of the time, but then every once in a while has kind of a hiccup or slows down a little bit. So you can set that filter, and then the next time their frame takes long enough, it will capture that one, and you can see why things are slowing down at that point. The other tool is the probe component. So this is something that is in the TouchDesigner palette. So you can open the palette, go to the tools section, scroll down here to probe, and then drag this into the project. Typically, you want to do this at the root, so not in project one, but outside of that. But you can technically put it wherever you want, but just kind of by convention, it's typically done there. So once that's loaded up, you can use the Control P shortcut, and that's going to open up this probe window. And this is going to show a visualization of a network of a component with all the work going on in it. So which component it shows is based on what's shown in this path bar here. So right now it's showing the root of the project, but if you wanted to go into project one, you could select that there, or you can click on the outside and it'll jump up a level. So this is showing our project one network. So if you look at the network here, you'll see that it's got the same layout there. For each operator in the network, it's going to show this stack of circles, and the topmost one is the latest frame, and then it shows 10 frames of history of the previous 10 frames. So you'll see that as things change, the top circle will change first, and then that will kind of ripple down the chain. And then for components like this base, it's going to show the combined activity of their inputs. So if we turn on a viewer here, and that's going to cause those inputs to cook, then suddenly we're seeing all of that work going on for that component and the stuff inside it. So this is a great way to get an overview of how costly different parts of your network are. And then when you're done, you can close the probe window. Having the probe component sitting in your project has a little bit of a cost, even if it's not open. And we can see that by looking at the performance monitor. And if we do another, and if we clear that frame trigger to 0 and hit analyze, then we'll see that up here there is some time going towards cooking the probe. So typically what you'll do with probe is drop it into the project, use it to figure out where those kind of like hotspots are and, adjust things or whatever, try to optimize it, and then remove it. And then the next time you need it, you can just pull it in out of the palette again. Optimization in TouchDesigner is a big topic, but understanding how cooking works is the basis for all of it. So to summarize, you want to have as few operators cooking as you can. Turning off operator viewers helps avoid unnecessary cooking a lot of the time. Switches are a great way to only cook one of several possible chains of operators. The performance monitor gives you an overview of the whole project and how long each operator took. But there's also some stuff in there that isn't tied to a particular operator and is more kind of under the hood of how TouchDesigner works in general. And finally, the probe tool is a good way to visualize the activity going on in a particular component and all of its subcomponents. There are a lot of other topics that are involved in optimization, which I'll cover separately, including shifting work to the GPU or avoiding having too many parallel chains of operators and like collapsing things into fewer operators or optimizing video file playback and so on. But hopefully, this was a good starting point to at least get a better sense of which parts of your project are costly. If you like this video and you want to support me making more of them, consider subscribing to my Patreon. You'll get exclusive downloads, early tutorial access, and a bunch of RayTK stuff. And even if you don't feel like paying, you can subscribe for free as a way to get announcements about RayTK or other tutorials that I'm putting out. Thanks for watching, and make sure to like, subscribe, and turn on the notification setting.